Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum
Up till
assalam.
now, we have completed five chapters of your book, first five chapters, in fact. And in previous class, we completed chapter 5 of your book, Survey of Probability Concepts. And today, we are interested in starting a new chapter, chapter 6 of your book, that is discrete probability distributions. So what we mean by discrete probability distribution, before that, you may know what is probability distribution first of all. So write down the definition for probability distribution first. What is probability distribution? Basically, it is a listing of all outcomes. Let me write down over here. It is a listing of all outcomes of an experiment. And the probability associated with each outcome, and the probability associated with each outcome. So basically probabilities are there, and we are interested in providing that information in form of a table where we basically distribute the probabilities in some specific format. So this is called the probability distribution. Then there comes the characteristics of the probability distribution. So if you see in your book, these are the slides, but better would be if I use your book. Let me open the chapter. So this is the definition that I have written over here: a listing of all outcomes of an experiment and the probability associated with each outcome. Okay, so what is this? We will see later on in some example. But before that, see the characteristics of the probability distribution. The probability of a particular outcome is between 0 and 1 inclusive. So we know that the probability is always from 0 to 1. Okay, it could not be less than 0, it could not be more than 1. 0%, 100%. Okay, 0 means 0 and 1 means 100%. 0%, 100%. So from 0% up to 100%, the probabilities may vary, and it could not be more than 100% or 1. The outcomes are mutually exclusive. So in case of probability distribution, outcomes are mutually exclusive. You are familiar with this concept that at one time, only one outcome will be there. So in tossing a coin, only head may occur or tail may occur, but both could not occur at the same time. So this is called the mutual exclusiveness. And then the list of outcomes is exhaustive. So the sum of the probabilities of the outcomes is equal to 1. So by exhaustive, we mean that if you are going to toss a coin, so it will definitely come on earth, means there will be some output. If you have tossed a coin, there will be some output. So it is not possible that you are going to toss a coin and there is no outcome. Outcome will be there. So outcomes are exhaustive. List of outcomes is exhaustive, and the sum of probabilities of the outcomes is equal to 1. So when you will add all those outcomes, the probability of all those outcomes, you will have 1 as your answer, as we have seen already in chapter 5. Now, let us see an example that is there in your book. If you see this example, suppose we are interested in the number of heads showing face up on 3 tosses of a coin. This is the experiment. The possible results are 0 heads, 1 head, 2 heads, and 3 heads. What is the probability distribution of the number of heads? So let me have a snapshot for this. Suppose we are interested in uh, tossing a coin. So basically, there are 2 possibilities. One is that there may be head. The other possibility is that the outcome is tail. So what you have to do? What is the probability distribution of number of heads? So now the probability distribution of number of heads you have to write down in form of a table. So for that you have to start it from this. Three tosses of a coin. There are 3 tosses. There are 3 tosses. So it means that let's say how many total outcomes will be there. The first question is this: how many total outcomes will be there? So for that, how many possibilities are there? If you are going to toss one coin once, if you are going to toss one coin once, the total possible outcomes in this case will be 2. One will be the success, the other will be the failure. So if you are considering heads, this will be your success. It means occurrence of head will be your success. So head or tail. So tail will be failure in that case, because you are considering heads as success. So if you are going one coin once, there will be 2 outcomes. Okay. And if you are going to toss 3 coins once, then again for each coin there will be 2 possible outcomes. This is one scenario. The other scenario is that you are going to toss one coin thrice. One coin thrice. So you can take 2 power 3. 2 power 3. Or otherwise you may consider the multiplication formula that we have already seen in the previous chapter. So if you are going to toss one coin thrice, okay, or 3 coins once, so what will be the multiplication formula? For first coin, there are 2 possible outcomes, head or tail. For the other coin, there will be 2 possible outcomes. For the third coin, there will be, sorry, 2 possible outcomes. So 2 multiplied by 2 multiplied by 2, the answer will equal 8. So you may obtain 8 by taking 2's power 3, or you may use the multiplication formula that we have already learned in chapter 5. So total 8 outcomes will be there. Total 8 outcomes will be there. So how could you write down these 8 outcomes? So you may write down over here table like this. Possible results possible results and first result, second result, third result. Okay. And here you may write down number of heads because you are interested in number of heads. If you are interested in number of tails, you may write down number of tails over here. So write down a table like this. So see, okay. The first possibility is that one. How many possible results will be there? Up to 8. 1, 2, 3, 4, 5, 6, and 8. There will be 8 possible results. Now see, first possibility is that you toss a coin and tail is there. Again you toss a coin, again tail is the result. And you toss the coin third time and again you see that there is tail. So 3 times tail is there. Okay. Then again you may see the outcomes may be like this. First time there is tail, second time tail, but third time head is there. Okay. The other possibility is that you toss a coin and it was tail on first attempt, it was head on next trial, and it was tail on third trial. Okay. Then it is also possible that head is there on first trial, tail and tail, these two are there on second and third trial. Okay. Now you may see the other possibilities. Let's say tail was there in the first trial, head was there on second, head was there on third. Then it is possible that head was there in the first trial, tail was there in the second, and head was there in the third trial. Okay. Then the other possibilities may be, what may be the other? So 7 is not there, so write down over here 7, 7, and 8. So another possibility may be that if you see over here, we have started it from T, THH, HTH, and it is possible that H, H, T, this is there. And finally, it is quite possible that you may have head, head, and head in 3 trials. So these are the possibilities, and there is no other possibility. Okay. So these are the total possibilities, total possible outcomes. Total possible outcomes are 8, and we have confirmed it. So now you have to write down the number of heads because you are considering heads as your success. So if you see the first result, tail, tail, tail. So there is no head. So you may write down 0 heads. In the second, you may write down there is 1 head. In the third, you may see 1 head is there again. Fourth, 1 head. And in the fifth trial, there are 2 heads. 6, 2 heads. 7, 2 heads. And in the eighth trial, 3 heads are there. There are 3 heads. So you will write down the table in this way. Now the next step is you have to see over here, what is the probability distribution of the number of heads. So we are basically interested in probability distribution. So how will you write down the probability distribution table? So again, there will be another table where you will write down number of heads, and in the next column you will write down the probability of outcome, probability of outcome, like this. Okay, so now you will see number of heads. Write down only once. Let's say number of heads 0 is there, so write down 0 over here, 0. Then 1 is there, 2 is there, and 3 is there. So you may write down 1, 2, and 3. These are the number of heads that are possible in this situation when we are going to toss one coin thrice. Now, what is the probability of outcome? So out of these, you can see total are 8, and how many times 0 has occurred? 1 time. So you may write down over here probability of outcome for 0, 1 by 8. Similarly, number of heads 1. How many times 1 has occurred out of 8? 1, 2, 3. 3 times 1 is there, and total total are 8. 8 possible results are there.
3
And
by 8, sir. 3 by 8.
sorry, yes, 3 by 8. Fine. 3 by 8. 3 times. 3 by 8. Then 2. How many times 2? 2 is 3 times out of total possible results that are 8. So 3 by 8. And similarly, 3 has occurred only once. It was heads. 3 times head were there. 3 times head was there in this trial. Head 3. Only once. So 1 by 8. Now, we know that the events are mutually exclusive and they are exhaustive. So the sum for these probabilities will equal 1. You may check it. It will be 1. You can see 1 plus 3, 4, plus 3, 7, plus 1, 8. 8 by 8 is equal to 1. So it means that we have distributed the probabilities. We have distributed the probabilities. We have given the probability to each possible outcome. Okay. So basically, in previous chapters, if you see before chapter 5, we were basically doing things from descriptive statistics, and now inferential statistics is there because we want to know here what will happen, what is going to occur in future. Okay, what are the possibilities of occurrence of anything? Okay, so we are now talking about chances of occurrences of things, right? So if I ask you to draw this information in form of a graph, so you may also draw it in form of a graph. Here on the horizontal axis, you may take x, and on the vertical axis, you may take p of x. So in form of graph, you may distribute the probability. So now this x is basically this number of heads. This is your x. And probability of outcome is this, p of x. So you may write down things. You may scale the axis 0, or you may start 0 from not from here, from slightly above this point 0. You may take over here 1, 2, 3, and this 0, let's say at this point there is 0 for 0 probability at this end. Okay. You may also take this 0 over here, but to avoid any confusion, we are taking this 0 slightly above this point. Okay, so these are the possible outcomes. And on the vertical axis, you may start writing probabilities from 1 by 8. Then there will be 2 by 8. Then there will be 3 by 8. Okay. Then there will be 4 by 8, and 4 by 8 will be equal to 1 by 2. And similarly, 5 by 8, 6 by 8, and finally there will be 8 by 8. Okay. So now for 0, when number of heads are 0, so So what will be the probability for this? 1 by 8. It is given. We have already seen. So you may draw a line like this. This line will raise up to this point. This means 1 over 8 is the probability that no head will occur in 3 trials. Then one head will occur in how many trials?
Three.
3.
Three.
So you may raise the line from this point up to this point, 3 by 8. Similarly, 2, 2
Again
up to
three.
this point. Then 3 once. So like this. 1 by 8. 1 by 8. So what is this? Probability distributions. You have distributed the probabilities. Now anybody can straightforwardly conclude by looking at this graph that two heads are there. Better would be if you write down over here number of heads. What is x? X, already we know that this is number of heads. But you may also give this information on the, please switch off your mic. Number of heads. Number of heads. X means number of heads. So we have distributed the probabilities that are for number of heads if you are going to toss one coin thrice or 3 coins once. So these are the all possibilities. Similarly, if I ask you to write down a probability distribution for number of possible uh, dots on a die. Okay. So I mean, if you are going to roll a dice once, write down probability distribution, dist dot means distribution table for number of possible spots, for number of possible spots or dots, for number of possible dots on rolling rolling a dice once. So how will you write down? There are 6 possibilities. If you see the dice, I think you're familiar with dice. Dice is there. These are the coins. Dice will be there in this slide. I think so. Dice that we normally use in Ludo. A cube on which we see there are 6 dots,
Yes, sir. Yes, sir.
5 dots, 4 dots, 3 dots, 2 dots, 1 dots on different sides. Cube. It is like this. You may see. The shape is like this. Okay. So 1 dot, 2 dots, 3 dots. To that side there are 4 dots, 5 dots, 6 dots, like this. Okay. So you have to see that if you are going to roll a dice once, how many possible outcomes are there? So you may write down over here
Six.
number of number of dots or spots, and here you may write down a column for probability. So number of dots are possible that are there on the dice, or we also call that die. 1, 2, 3, 4, 5, and 6. So I normally say dice, but you will see die is written there in your book. Dice is basically singular, and die is plural, but dice is also used as plural. Okay, no problem. So dice is better to use this word. Okay. So now probability. One may occur out of six. This is the probability. Two may be there as a result. I mean, two dots face up. So you can see if you use that formula, how many possible outcomes are there? Six. And you are going to toss a coin. You are going to roll a dice once. So you may take power one. So answer will be six. So there will be six possible outcomes, six possible results. Okay. And if you are going to roll a dice twice, then six possible outcomes, power 2, 36 will be there. 36 outcomes will be there. 36 possible results will be there. Okay. So in this particular case, when you are going to roll a dice once, only six possible outcomes will be there. 2 by 6, 3 by 6, 4 by 6. Sorry, no. Sorry, let me correct it. Let me correct it. It will be basically 1 by 6 for all cases, not 3 by 6. You can see the probability. 2 may occur once. 2 may occur once in one roll. It means the probability for that will be 1 by 6. 3 may occur once in one roll, 1 by 6. Similarly, 4 may occur once, 1 by 6. 5 may occur once, 6 may occur once, 1 by 6. So when you will add these probabilities, the answer will be equal to 1. And if I ask you to show the probability distribution on graph, you may draw the graph like this, Tx, and here x, and now x means number of dots on cube or on dice. So here 1 by 6 will be there, then 2 by 6 will be there, then 3 by 6, 4 by 6, up to 6 by 6. Okay, and here are the numbers 1, 2, 3, 4, 5, 6. So 1, the probability for 1 is 1 by 6, for 2 1 by 6, for 3 1 by 6, for 4 1 by 6, right? For all 1 by 6. So this will be the probability distribution in this particular case. Fine. So you can see this example from here. Okay, you may write down probabilities in this way. 1 over 8 is equal to 0.125 like this. But the sum is this, no problem. So the possible outcomes of an experiment involving a roll of a 6-sided die for a 1 spot, 2, 3, 4, 5, 6. So I have done this for you. I have developed a probability distribution for the number of possible spots in form of a table, and portray the probability distribution graphically. So I have already portrayed. And what is the sum of the probabilities? I have already said that the sum will equal 1. So I have solved this self-review 6-1. Then comes random variable. What we mean by random variable? A variable measured or observed as the result of an experiment by chance. The variable can have different values. The variable can have different values. Then there are two types of random variables. One is discrete and the other is continuous. So what we mean by discrete random variable? A random variable that can assume only certain clearly separated values. Okay. And if the values are not clearly separated, then definitely they will be continuous. So that variable will be called continuous random variable, in which there are no certain gaps in between the outcomes. Okay. So let us see some examples for this. So this is continuous random variable, you can see it. And then mean, variance, and standard deviation of the discrete probability distribution. This is another concept, that how can we find out the mean and the variance in this case when we are talking about probability distribution. Okay. So the formula for mean is, you are familiar with mean. What we mean by mean? Average. So the formula for that is mu is equal to summation xpx. xpx. This is the formula for average or mean. And variance of probability distribution, what will be the formula for that? Variance of the probability distribution. So sigma square, this is equal to summation into x minus mu whole square. So spread from mean position, squared deviation, multiply by the probability px. So what are we doing? We are basically giving weights to the values. We are basically giving weights to the values to find out the average and the variance. Okay. So then there is an example in your book. You may also see quickly this example. This example. John Rexdale sells new cars for Pelican Ford. John usually sells the largest number of cars on Saturday. He has developed the following probability distribution for the number of cars he expected to sell on a particular Saturday. So, what type of distribution is this? What type of distribution is this? So, you will say that this is the discrete probability distribution because one car will be sold, or two cars will be sold, or three cars will be sold. But you can't say that 1.5 cars will be sold. You can't say that 1.3 cars will be sold. Okay? So clearly separated values are there. Okay? So therefore, this is discrete probability distribution because certain gaps are there. And if you see this, this graph, this is an example of discrete probability distribution because certain gaps are there in between the values. And if you see this graph also, certain gaps are there. You can't say that uh, 1.5 heads are there. No, one head will be there or one tail will be there. One complete value will be there. Okay. So you may see this example. On a typical Saturday, how many cars does John expect to sell? On a typical Saturday. By typical Saturday, we mean that on average, on any single Saturday, on average, how many cars this seller is expecting that these will be sold. So you have to find out average. Typical Saturday means you have to find out average. And what is the variance of the distribution? It means that it is clear that you will find out sigma square. So let us quickly solve this example. Better would be if I explain it from here and I solve the self-review. So you can see over here, better would be if I solve it from, because the example is there already solved. Okay. So mean, mu is equal to summation xpx. So for xpx, you have to find out the product of these two, xpx. So for this, you have to write down the values that are their number of cars sold from x 0, 1, 2 up to 4. This is given over here in this table. Probabilities are given, write down the probabilities and simply multiply xpx. each value with the other value. So basically, this point 1 is the weight of 0. Point 2 is the weight of one car sold, like this. So in total, you will obtain as average this value. Mu is equal to 2.1. So, but you can see that 2.1 cars are not possible to be sold on average. Although on average this is possible, but you can see that 2.1 cars, what this means, 2.1 cars. Okay. This doesn't mean anything. The car should be 2 or 3, not 2.1. But this 2.1 may help you in the case when you are considering, let's say, 50 Saturdays, as it is given in your book. If you are going to consider 50 Saturdays, so on any particular Saturday, how many cars will be sold? Okay, so you may multiply 50 with 2.1. So the answer is 105. So you can see over here 105 cars just on Saturdays. So for example, if John works 50 Saturdays during a year, he can expect to sell 105 cars just on Saturdays. So on all Saturdays that will be there during the year. Let's say 50 Saturdays are there. So simply on Saturdays he will be selling 105 cars. So this may help when you are going to take more than one Saturday. So because in that case you will have a figure like this 105. Then you are interested in finding out the variance, and for variance this is the formula that I have written over here. This is the formula. So we have to find out average that you already have found 2.1. So you will write down 2.1 over here, and x you will write down different values for x, and finally you will have a column that will give you the product of these two terms, and then you will finally add these the values that will be there in this column. So the solution will be like this: number of cars sold, probability, x minus mu, all these values, 0 minus 2.1, 1 minus 2.1, like this. Then takes care of these because the sum for this will be equal to 0. We want to avoid the situation, and therefore we are taking sum. Therefore, we are taking square of these two terms. This square deviation. This is the square deviation from mean, and then multiple of these two terms. Finally, 1.290. This is the variance, and when you will take square root of this, you will have standard deviation, because you know the standard deviation is square root of variance. So you can see over here. We would conclude that there is more variability in the Saturday sales of Miss Kirsch than in those of Miss Ragdale. So there is, I think, a question. Recall that the standard deviation sigma is the positive square root of the variance. In this example, sigma square is equal to 1.29, and square root of this is 1.136 cars. How do we apply a standard deviation of 1.136 cars? If salesperson Rita Kirsch also sold a mean of 2.1 cars on Saturdays, and standard deviation in her sales was 1.91. So you can see that standard deviation in this case, when Rita is selling the cars, is 1.91. So this standard deviation is larger. This value is larger than this value. That is for the other person that's name is Ragsdale. So we would conclude that there is more variability in Saturday sales of Miss Rita. Okay. Although means are equal, but variability is more in case of Rita. The variability of sales, the variability in sales of cars on Saturdays is larger in case of Rita as compared to Rexdale. Okay, so you see that variance is very important, and it will help you in understanding that where is the more variation, in which case there is more variation. Then you can see this self-review. The Pizza Palace offers 3 sizes of cola. The smallest sells for $1.99, medium for 2.49, large for 2.89, 30% of drinks sold are small, 50% medium, 20% large. Create probability distribution for the random variable price and answer the following questions. So in this case, you have to write down the probability distribution first. So how will you write down the probability distribution in this case? Yes. How will you? Anybody?
Yes, sir.
Can you write down? Simply, you can see that probabilities are given and sizes are given. So it is very easy, not difficult. Simply give, let's say in this case, uh, offers three sizes of cola. So cola sizes may be considered as random variable. Cola sizes may be considered as random variable that you will written over here. Cola sizes means X. Okay. And probability of X means probability for different cola sizes. So what are the values for X? 1.99, and the probability for this 1.99, 30% of drinks sold are small. So these are the smallest size cells for 1.99. So cola size $1.99 and smallest. So for this particular size cola, 30% sales are there. Okay, so 30% means 0.30. You may write down here P of X is equal to 0.30. The next value in dollars, 2.49 for medium size, 2.49. So right now 2.49. Similarly, probability for this, 50% for medium, so 0.50. Then 2.89, and probability for this is the remaining value, that will be 20%, 2.20. Right? And sum for probabilities will definitely be equal to 1. Okay, so now you are interested in answering the questions because you have written the table. Is this a discrete probability distribution? Indicate why or why not. Yes. Is it a discrete probability distribution? You will say yes, it is a discrete probability distribution. It is a discrete probability distribution. Why? Because there are certain gaps in between values. Because there are certain gaps in between values, there is no continuity. There is no continuity. So I mean, if you draw the probabilities in form of a table, you may see, let's say 1.99 is the value over here. The next value is 2.49, 2.89, 2.49, 2.89, let's say. So you may see if the probabilities are like this, starting from 0%, then 10%, 20%. So you may take it as 20%, 40%, 60%, 80%, up to 100%. So 1.99, what is the probability for this? 0.30, 30%. So you may raise this line from this point up to 30%. 30% will be in between 20 and 40%. 30% will be in between 40 and 20%. Similarly, 2.49. For this, it was 50%. So you may raise the line up to 50%. That will be in between 40 and 60, like this. Then 20%. This is 20%. So you may see that certain gaps are there. There's no continuity. There is no continuity. Continuous probability distribution we shall see in chapter 7 of your book, where you will see that normally in case of time, as time changes after you can say after every moment. So continuous time is a continuous variable, and there are so many other continuous variables. So in that case, continuity will arise in the distribution, and because of that, we will say that this is the continuous probability distribution. But in this case, this is the discrete probability distribution because certain gaps are there. Compute the mean amount charged for cola. Charged for cola, mean amount. So for mean amount, you will recall the formula, and the formula I have just seen over here. This formula xpx, summation xpx. So simply multiply these two, xpx. You will have the answer. And then what is the variance in the amount charged for cola? The standard deviation. So once you will be able to find out variance, you will simply take square root of that to have the uh, standard deviation. So for that, what will be required? You will need this term x minus mu whole square into p of x. So for this, you have to write down another column for x minus mu, and then for x minus mu square, and then x minus mu square multiply by p of x. So two columns may be written in between these two, but for the sake of space, I'm not writing down those two columns. I've skipped two columns, but you know this. X px, now simply multiply these terms. So if you have calculator with you, we can solve it. Otherwise, we will move to the next question. So if idea is clear, then we may move onward. Yes. What is your opinion? Should we solve it or move onward?
Okay, mu square
As you
x
wish, sir.
ये x minus mu square इसको किस तरह minus
I
करेंगे?
think it is very easy. You can solve it. Is there anybody who is unable to solve this question? No, everybody can solve.
Inshallah, sir, we solve.
Yes, 1.99 multiplied by 0.30. This will be the answer. If you have calculator with you, you can tell me the answer. 2.49 multiplied by 0.5. What is the answer?
1.245.
245, like this. 2.89 multiplied by 0.20.
0.578.
578, like this. And in this column, x minus mu square. So for mu square, we have to add these values. So simply add plus 1.245 plus 0.597. The answer is 2.42. So 2.42 is your mu. This is your mu. So now subtract this 2.42 each time from these values. 1.99 minus this value. 2.49 minus this value. 2.89 minus this value. Whatever will be the answer, you will take care of that. And then you will multiply that with this column one by one. Finally, you will have the variance. And when you will take square root of this variance, you will have standard deviation. So you can do it. Then these are the questions that are there in this section. You may solve these questions, and if you feel any problem, you may ask me in the next class. So very easy. If you see, let's say this question, frequency. So in this case, if you see frequency is there, probabilities are not there. Okay, so I think so you can see probability is there, frequency is there. In this particular case, again, probability is not given, frequency is given. So this is your assignment. you, not assignment, but your activity, that you have to solve this question. But I am going to solve this question number 5. But question number 5, the answer for question number 5 will be there in your book. So which question should I solve, 8 or 5?
8 says.
The Downtown Parking Authority of Tampa, Florida, reported the following information for a sample of 250 customers on number of hours cars are parked and amount they are charged. Number of hours, amount charged, and this is the frequency. So number of hours is equal to 1. This is one series, and amount charged, this is another series. Okay, and frequency is same in both cases. Let's say in this case, how many times $3 were charged? So you will say 20 times. For 1 hours, okay, how many cars were parked? You will say 20, like this. So in total, there are 250 customers. In total, there are 250 customers. So 250 customers means 250 cars. Now what is required? Convert the information on number of hours parked to a probability distribution. Is this a discrete or continuous probability distribution? You will say that this is a discrete probability distribution because there are certain gaps in the probabilities. So you can see over here how there are certain gaps in, let's say, in number of hours and in the amounts charged. There are certain gaps. So how can you convert this information in form of probability distribution? So you may write down over here, first of all, number of hours, and the next column will be for frequency. Okay, you may write it down as F or completely frequency. And as you are interested in number of hours, convert the information on the number of hours parked to a probability distribution. So he's not talking about amount charged. He's talking about number of hours. So you may write down these values over there in the column 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Then frequency and frequencies are given over here. These frequencies. So anybody can help me in writing down these probability frequencies. 20, 38. If you have a book in front of you, yes, 20, 38,
33, sir.
33,
53.
53.
No, sir. In 33, it's 53.
33, sorry.
53. Yes.
38,
53.
38 and 53.
53, yes.
And
45.
let me correct it. 38, then 53, then
45.
45.
45,
40.
40.
13.
13.
15.
5.
13, for 6 it is 13,
Yes, 13.
then
5.
5.
5,
36.
36.
36. Thank you. So these are the frequencies, and we are now interested in relative frequency, or we also call that relative frequency probability. So you are familiar with the concept of relative frequency, in which we take relative frequency, that relatively in relative terms, what is the frequency. So in this case, you may write down RF, or you may write down probability of X. Probability of X in this case will be simply 20, this 20 divided by total, and total is 250. Okay. So 20 divided by 250. What is the answer? 20 divided by 250. 250 is the total, and out of
0.08.
total, the share of first is 20. So it is
0.08.
0.08.
0.08, like this. Similarly, for second, 38.250. What is the answer?
0.152. 152.
0.15. 53 divided by 250.
0.21.
0.21.
21.
2.
Okay. Better would be if you take it up to 3 decimal points. Okay. Then,
0.18.
if you are using it up to 2 decimal points, then all figures should be up to 2 decimal points. Then 40 divided by 250.
0.16.
0.16.
0.16. 13 divided by 250.
0.05.
0.05. 5 divided by 250.
0.02.
0.02. 36 divided by 250.
0.14.
1.4. So answer for these must equal 1. You may add. If there is some issue, exactly it is not equal to 1, it means that there is some issue of rounding off of figures. Okay? Because you are rounding off the digits, therefore it may be slightly above 1 or slightly below 1. But in fact, if you take into account all up to all decimal points, all figures, then it will exactly equal 1. Now, what is required? Is it discrete or continuous? So you will say discrete. And to a probability distribution, we have basically converted the information into a probability distribution. We have converted. So probability distribution is now there. Right? What next? Find the mean and the standard deviation of the number of hours parked. How many would you answer? How would you answer the question? How long a typical customer parked? So again, typical means average. On average, uh, a customer parked a car for how many hours on average? So for that, you will definitely have this mean. This mean. Find mean and standard deviation. So mean, if there, only if you calculate mean, the answer will be there. Similarly, standard deviation. So here you can write down for finding mean x px. So again, simply multiply and have the answer in form of summation of this. So when you will take summation x px, whatever answer will be there, that will be your answer. Okay. And similarly for variance, you will write down this this formula, x minus mu whole square into p of x. So you will have a column for this term. Right? I think you can do on your notebook. X minus mu square multiply by p of x. So I can only write for 1 or 2 values. X minus mu. X is this. This is basically your x. Okay. So 1 minus average value. What is your average value? For this, you have to add all those values. That will be the multiple of these two. Okay. So should we solve it or leave it over here? It is not difficult. If you have calculator with you, we can solve it in 2 minutes. 0.08 multiplied by 1. The answer is 0.08. 0.15 multiplied by 2. The answer is 0.30.
304.
It is verbal.
30.
0.21 multiplied by 3. The answer is 0.42 and then
63.
64 when you round it off. And 0.18 multiplied by 4. 72.72. Then 0.16 multiplied by 5, 0.80. So it is verbal. If you don't have calculator with you, even then you are able to. You simply multiply this 16 multiplied by 5 and then 0.05 multiplied by 6,
0.3.
0.3. Okay. Simply 0.3 or 30 or 31?
3. Just 3. 0.3.
Simply 3. 0.05 multiplied by 6. Okay. 0.02 multiplied by 7.
Point
0.14.
14.
0.14 and 0.14 multiplied by 8.
1.12.
15. So now add these values. 0.15 multiplied by 0.14, sorry, 0.15, 1.15 plus 0.14 plus 0.3 plus 0.8 plus 0.72 plus 0.64 plus 0.30 plus 0.08. The answer is what is your answer? Do you have these values in front of you?
Yes, sir.
Yes, sir.
Simply add these values.
4.114.
4.14. So this is your average. So what will you do? You will use this value
1.
and you will take these values. 1 minus, in this case it will be 1 minus 4.14 square
4.11, sir.
4.11.
11. Yes, sir.
4.11.
Yes.
Okay, so whatever value is there, let's say it is 4.14, then you will write it down 1 minus 4.14. If it is 4.11, you will write down 4.11. Whatever mean is there, no problem. You will use that value. If it is 1, so 1. So correct it also over here. So now 4.11. 4 minus 1 minus 4.11 whole square multiplied by probability of x. Probability of x, this is there, 0.08. 0.08. So in this way, you will write down for all values, and finally you will have the sum. That value will be your variance, and then you will take square root of that to have the standard deviation. So you have to find it out. Now come to next part. Find mean and standard deviation of amount charged. Amount charged. So from this table, now you will not use these values because these are the number of hours we have already used. Now you will consider these values as x. This was x, or you can say this was x1, and now these values are there. These may be called as x2. So let's say now we are writing these values, amount charged. Amount charged. And then frequencies for this. Frequencies are same. So I'm just simply writing down few values. 3, 6, 9, 12. 3, 3, 6, 9, and 12. And frequencies for these values are 20, 38, 53, 45. 20, 38, 38. What next? 53. And what next?
45.
45. So 45. So similarly for other values, you will write down up, up to end. And then these are the frequencies and then probabilities. So how will you find out probabilities? You will write down 20 divided by 250. So same, this you will obtain this column, probability of x. So probability of x will remain same. So you simply if you are considering these separately, you may write down over here 1 x1, and it will become x1 x1 x1, and probability of x1 is equal to probability of x2, because x1 is number of hours and x2 amount charged. X1 is equal to x2, or you can separately solve it as I am doing over here. So it's upon you. Probabilities, the column of probability will remain same, 0.08. The next value was
0.
0.15, 0.15, 0.21, and finally it was for fourth value 0.18.
0.18.
So 0.18, and for remaining values you will do, because I don't want to waste time on this. You can easily do it. Probabilities are there now, because we were not interested in frequencies, we were interested in probabilities, because we need probabilities in the formula. Probability of x. So these are the values for x, or you may write it down as x2 and then probability. So if you are going to write down it as x2, then probabilities will be probability of x2. So these values will be there, and simply then you will multiply x2 into p of x2 to have mean. And similarly then you would have another column for x2 minus mu whole square multiplied by probability of x2. So this will give you the variance and the standard deviation finally. Fine. I think it is clear. There shouldn't be any problem in solving this question.
Yes, sir. Inshallah.
So if frequencies are there, you can easily find out the probabilities. No problem. There shouldn't be any problem. Then comes binomial probability distribution. So basically under the head distribution, binomial probability distribution. Basically in discrete probability distribution, under this head, there are so many probability distributions that could be written with certain gaps, when random variable x has values with certain gaps, where random variable x has values with certain gaps. So there are so many probability distributions, and we would only consider three out of those so many. So one is binomial probability distribution. The other that we will consider is hypergeometric, and finally we will talk about Poisson probability distribution, and that will be the final topic of our course Statistics 1 in this semester. So let us see under the head probability distribution, and particularly discrete probability distribution. The first discrete probability distribution is binomial probability distribution. And what is this binomial probability distribution? uh, you can simply see from its name, by means two. By means two. So when you are going to perform an experiment and there are two possible outcomes, only two possible outcomes, then you will say that this is an example of binomial probability distribution, where there are only two possibilities, where there are only two possible outcomes. One may be considered as success and the other may be considered as failure. So if you are going to consider the number of heads, for example, in tossing a coin thrice, so that will be your probability of success. And you know there are only two possibilities, either head may occur or tail may occur. So if you are considering tail as your probability of success, so you may also consider that in that case the occurrence of head will become failure. So basically there are two possible outcomes, success and failure. In case of coin, there are two possible outcomes. What are those two? Uh, Head and tail. Similarly, if you are going to ask some question from somebody and you say that only two answers, out of two answers, one answer may be there. Either he may say yes or he may say no. So if you want to attend the class, there are two possibilities. You want to attend or you don't want to attend. At the same time, it is not possible that head is there and the tail is there at the same time. No. Similarly, if somebody has said yes, at the same time, he can't say no. If he is going to say yes, so that will be a response, noted response. Otherwise, if he is going to say no, so he can't say at the same time yes. And if you say he remains indecisive, so we are not considering that situation. We are only considering that there are only two possibilities. He must have to say yes or he must have to say no. He may not remain indecisive. So in that case, you will consider the binomial probability distribution. So if you see the characteristics of the this binomial probability distribution, you can see from your book. Uh, you can see from here. Uh, an outcome on each trial of an experiment is classified into one of the two mutually exclusive categories, success or failure. The random variable is the number of successes in a fixed number of trials. The probability of success is the same for each trial. So probability of success will remain same in each trial, means if you are going to toss 10 coins, okay, so for each coin, the probability of occurrence of head, let's say you consider as success, so that will remain 50%. If you are going to toss a coin, the probability of occurrence of head or the chance of occurrence of head is 50%. If you are going to toss again 50%. If you are going to toss it 100 times, even then for each trial, the probability of success will remain same, 50%. So this is the characteristic that you will consider in case of binomial. And the fourth characteristic is that trials are independent, means that outcome of one trial does not affect the outcome of any other trial. So it means that if you're going to toss a coin, head is there, then it doesn't matter that head is there or tail is there for the next trial. So when you will go for next trial, head may occur again or tail may occur again because these are independent. Okay. So trials are independent. Okay, so then there is a formula for this, how binomial probability is computed. So this is the formula, but I'm going to change this formula and I'm going to use my own notations instead of these pi's, because in the next course you will see this pi for population proportion. So it is quite possible that you get confused that what is this pi. So therefore I'm going to change the notations and I'm going to use those notations with which you are familiar. So the formula for binomial probability distribution that I will also prove in few minutes is this: probability of x. Capital X is the number of successes in population, you can say, and small x is the number of successes in sample. So this is equal to n c x. N means number of trials, you may say, number of trials, and x number of successes in sample, and C indicates the combination. So this is the combination formula that we studied in the previous lecture, where we talked about principle of counting. So this was one principle of counting, combination formula, that we solved several examples for using this formula, NCX. And in case of permutations, it was NPX. And the third was multiplication rule. So here the combination formula, NCX. And then there is P. P is the probability of success. P is the probability of success. And here the power of this P will be X. Fine. And then you will write down Q. Q is basically the probability of failure. Q is basically the probability of failure. And this Q will raise to the power n minus x. This is the formula for binomial probability distribution. So now first try proving this formula, and then we would solve few questions from this section, and we will see that how can we use this formula in different situations. So let us derive this formula first. The derivation is not there in your book, so therefore you may take notes, and you may retain it in safe custody. Derivation of binomial probability distributions formula. Right, derivation. Let an experiment has let an experiment has n trials, or n number of trials, of which success or failure may occur. Let's say, so n number of trials. So let's say if you are going to toss a coin 2 times, so 2 is the number of trials. If you are going to toss a coin 10 times, so 10 is the number of trials. If you are going to toss a coin n times, so n trials. N trial means you are going to toss a coin n times. So definitely head will be there or tail will be there. So success and failure, you have if you have defined the success and failure, let's say the occurrence of head is success, then this will be the success in all cases. Okay? And if failure is T, so it will remain tail in all cases. And if you are going to consider, if you are considering failure as tail, the occurrence of let's say the occurrence of tail is your success, then the occurrence of head will be your you can say the occurrence of head will be considered as failure. So normally we take occurrence of head as success. Okay. In case of the response of somebody, let's say yes or no, so you may consider yes as success and no as failure. So the sample space has n 2 power n possible outcomes in this case. The sample space the sample space sample space has 2 power n 2 power n possible outcomes. What this means? This means that when I tossed a coin thrice, there were 8 possible outcomes. Why? Because I took 3 over here at instead of n. 2 power 3. The answer was 8. I have just solved. So 8 possible outcomes were there. So if there are n trials, there will be 2 power n possible outcomes. Is it clear? Say yes or no.
Yes, sir. Yes, sir.
Okay. So now see. If I say probability of 0 success in n trials. What is the probability of 0 success in n trials? Probability of 0 success, 0 success in n trials. What this means? Probability of 0 success in n trials. What this means? Probability of x is equal to 0. Okay, and it will equal to what? Probability of f is for failure. Probability of f, failure. So you may write it down as let's say f, again f, again f, n times f. Every time failure is there. I mean, if you are going to toss a coin, so tail is there every time. Okay, there is no head. It is quite possible. Is it possible? Yes,
sir.
it is possible. It is possible. Every time tail is there. Okay, so the probability that 0 head will occur means there is no s in this. There is no s in this means there is no success. Every time failure is there. No success means head is not there, or if you are going to consider head as s equal to s, then s is not there. And if I ask you that what is the probability that one success is there? So if you are talking about coin, then head is your success, for example, then you may write it down as probability of, let's say, s. Probability of s. Success is there once and then failure is there for the remaining trials. Understand? Clear? If x is equal to 2, then 2s will be there. If x is equal to 3, then 3s will be there. And these moves up to n times. Okay. This is the nth term. This is the nth term. Clear? So now let us consider the first equation. This is the first. Let's say this is the first equation. This is the first equation. This is the second equation. Let's say. Then for first equation, if you see, we are saying that these outcomes are independent. These outcomes are independent. So these are independents. The occurrence of tail is not depending upon occurrence of head. Occurrence of head is not depending upon the occurrence of tail. Both are independent. Are they independent? Yes, they are independent. So if they are independent, and if you recall the multiplication rule, one was the multiplication formula and the other was multiplication rule, where we were considering the dependency of the events. Can you recall that? We studied two things: addition rule and multiplication rule. So in addition rule we used union, and in multiplication rule we used intersection sign. Okay, and when intersection was there, we were considering dependency. So if you say if I write it down as probability of, let me write it down as probability of x is equal to 0. This is equal to probability that failure is there, and failure is there, and failure is there, and so on, and failure is there, and times failure is there, and events are independent. So independent, so intersection size is there. It means you will use special rule of multiplication, and in special rule of multiplication you will multiply the terms, the probabilities, pf multiplied by pf multiplied by so on up to pf. Is it or not?
Yes, sir.
Is it or not? Yes, it
Is
is.
it?
Yes, according to multiplication, special rule of multiplication, independent events. Then if I say, let's say probability of f, probability of failure is equal to q. Let's say probability of failure is equal to q, and probability of success is equal to p. So let's say probability of f is equal to q. Then you can substitute q here. Probability of f is equal to q. Then q multiply by q, so on up to multiply by q. Is it or not? So when you will write down here q up to q, probability of failure. So you may write it down as q power n, because this is the first term, second term, third term up to n term. So when you will take q power n, all terms will be there. I mean q1, q2, q3 up to nth term. Right? And when you will take this second equation into your account, probability of x1, and again for equation 2, you may write down as probability of x is equal to 1. So probability of s, and then failure, then failure, then so on up to last term failures are there. Again, events are independent. So if they are independent, then probability of s multiplied by probability of f multiplied by probability of f up to so on up to probability of f. Is it or not? Then you are saying that probability of f is equal to q and probability of s is equal to p. So now substituting these, you may have the equation as p multiplied by q multiplied by q, so on up to multiplied by q. I have written q for probability of f, and for probability of s I have written p. So p is there only once and q is there for n minus 1 times, because in total there are n terms. So one term is p, so remaining terms are n minus 1. So here you can write down probability of success is p power 1, and probability of failure is n minus 1. N minus 1. Why? Because there were total n terms here. One term is success and the remaining are failure. So one is out. P power 1, q power n minus 1. Right? So here you can see when it was, let's say, when you will consider this situation, success is not there. In these terms, success is not there. So if you write down over here p power 0, so p power 0 will become equal to 1 because there is no success. So p power 0 is there, in fact, p power 0. But we are not writing that because we know that p power 0 is equal to 1. Similarly, if you see this, p power 1 is there. Okay, so p power 1 is equal to p. And similarly, when one term is a success, the remaining terms are n minus 1 terms. So if let us say x is equal to 2, so this will become 2, and here n minus 2 will be there. Understand? Let's say you are going to consider x is equal to 10. So this will equal p power 10 and q power n minus 10. Understand? So this is that 10 and this is that 10. So you can consider 1, 1. And 0 we have not written over here because p power 0 is equal to 1. Simply qn is there. So now you will write down one or two sentences over here. The probability for, write down over here, the probability for any possible sequence, because these are the series. So probability of any possible sequence of one success, one S and n minus 1 failures, n minus 1 failures is p q power n minus 1, that we have just written over here, p power 1 q power n minus 1. So one success and n minus 1 failures. And what we mean by this, any possible sequence, this means that you may write down S over here, S intersection F, or you may write down F intersection S intersection F. It means first time success was there, then failure was there for the remaining terms, for the remaining trials. Okay, or it is quite possible that first time it was failure, second time success, and then failure again up to n. Or for all terms there were failure, but for the last term there was success. So success may be written over here or here or here, but it has occurred only once. So it doesn't matter that where it has occurred, at which trial it was there. Okay, but the question is this, that it has occurred only once. So if it has occurred only once, then this will be the situation, p power 1 q power n minus 1. So this is, so we are not going to write down p power 1 over here, because we know that this is equal to p power 1 is equal to p. Fine. So now if I write down, but the statement continues, full stop, then write down, but the number of mutually exclusive sequences, for mutually exclusive, I'm writing down ME, mutually exclusive sequences. Mutually exclusive sequences or events mean one may occur once. If success is there, failure is not there in one trial. In second trial, there may be success. In third trial, there may be failure. In fourth trial, there may be success or failure again. But in one trial, there will be success or failure once. In one trial, one outcome will be there, not two. So, but the number of mutually exclusive sequence in which one S, one success, one S, and n minus 1 failures can occur. Number of, we are basically interested in that in how many ways this can occur, that success is there once and failures are there for the n minus 1 times. N minus 1 times and one time success. So if success is, let's say, if you have already seen that we saw the situation, if first trial success is there, then what occurred? Failure is there. What occurred? Failure is there. So on, failure is there. This is one sequence. The other sequence may be failure is there, success is there, and then failure is there, so on up to failure is there. Another possibility is F is there, F is there, F is there, so on up to S is there finally. So how many ways, how many possible ways of occurrence of one success and the remaining failures are there? How many ways this can occur? How many sequences may be there? Can you? I think you can follow me. How many ways one success may be there and n minus one failures can occur or may be there. So for this, you will write down here n c one NC1. What this means? Combination. Out of total trials, one success is there. One success is there. Okay. Let's say in this case, one is there. So you may say that one success is there and the remaining terms are for failure. Okay. So you may write down, you may continue this curve can occur is NC1 is NC1. So exclude this. Don't write this because this was for you. For your understanding, I have done this. For your understanding, I have done this. The sentence continues. Full stop is there. Full stop. And then write down therefore. Therefore, so you may make fair notes for this. Therefore, the probability of exactly, the probability therefore the probability of exactly exactly one success, exactly one success, the probability of exactly one success for for all possible sequences combined is colon, and then you have to write down over here probability of x is equal to 1. It means probability of success is equal to 1 in this case. So NC1, and then we have proved this probability of P1. This is the probability of success, and Q was n minus 1. So this will be the case when there is only one success in nth trials. Okay. So what is your opinion that if P x is equal to 2, then it will be NC2 P power 2 Q power n minus 2. Similarly, so on up to 3, 4, 5, 6 up to probability of x is equal, if I write it down as x small x, x is equal to x, it means that x small x may take any value. Then you will write down n c x, p will power x and q will power n minus x. Is it clear?
Yes, clear.
Clear. Because when it was 2, it was here 2, 2, 2. When it was x, so x is there, x is there, x is there. So this is the binomial probability distribution formula. Fine. So now this formula is very, very useful. This formula is very, very useful. And I normally give the example that you normally know, a plus b power, let's say you are familiar with this, square. So what will be the answer? A square plus
B square
plus
plus
2ab plus
B square.
plus b square. This is the formula. And let me write it. This is b square. This is b square. Fine. And if it is x plus y square, x plus y whole square, so this will be x square plus 2xy plus y square. Am I right?
Yes, sir.
If I write down a plus b cube, it will equal a cube plus b cube plus, if you recall your memory, 3ab into a plus b. Right? This is the formula. that we normally use in mathematics, right? But we can take help of this formula. We can take help of this formula to have these terms. How? Let us see. Let us see. It is a plus b square whole square. Then what is n over here? 2. What is n? N is 2 in this case. Fine. So you may write down here 2. What can you write over here? You can write down 2. And then 2c 0. This will be the first term. 2c 0. Then probability of success, if you consider this A as probability of success, you consider this A as probability of success, and you are saying that there is no success, so you will take power 0. It means A is not there, success is not there. And if success is not there in 2 trials, then failure will be there in 2 trials. Am I right? I mean, if you are going to toss a coin twice, and on first trial there was no head, you may write down A power 0, no head occurred. Then no head occurred mean the if no head occurred in 2 trials, it means that in both trials tail has occurred, B power 2, right? Plus the next term that you will write down will be NC 2C1, NC1, or if this value was n, then it will be NC1. If it is 2, then 2C1. If it was 3, 3C1, 3C0, starting from 0. 2C1 into now A power 1, this one, A power 1. Now success is there once, and B2 minus 1. So 2 minus 1 is 1. So this plus the third term will be 2C2, and you can't go beyond this because 2C3 is not possible. You may move up to 2C2. Finally, there may be NCN. Okay, the final term may be NCN. So 2C2 if 2 is there. If n is equal to 2, so the final term will be 2C2. 2C3 is not possible. 3C2 is possible. 3C2 is possible, but 2C3 is not possible. This is wrong. This is fine. Fine. Okay. So 2C2, and now A power will be 2 and B power will be 2 minus 2, 0. So now if you will solve it, what is 2C0? 2C0 is equal to 1. You can check it from your formula, from your calculator. 2C2, 2C0. So this will become 2 factorial divided by 0 factorial. I mean, this if this is if you consider it as R, as we have considered in the principles of counting. So NCR. So if this is R, or if it is x factorial into n minus x factorial, or n minus r factorial, 2 minus 0 factorial. So when you solve it, it will become 2 factorial divided by 2 factorial. The answer is 1. So for this term, the answer is 1. For A power 0, the answer is 1. So you will remain with B square. So write down that B square over here, B square plus 2C1. 2C1 is equal to 1. 2C1 is equal to 2. 2C1 is equal to 2. You can check it. 2 factorial divided by 1 factorial divided by 2 minus 1 factorial. So the answer will be 2 factorial equal to 2. Then A power 1 and B power 2 minus 1 mean 1. So 2AB. This will be 2AB. And for the third term, you can see 2C2 is equal to 1. 2C2, as 2C0 is equal to 1. Similarly, 2C2 is equal to 1. Why? Because 2 minus 2 will be there over here. 2 minus 2 is equal to 0 factorial, and 0 factorial will equal 1. So the answer will be 1 in this case. You can see. Can you do it? 2C2. This will be 2 factorial. divided by 2 factorial into 2 minus 2 factorial. So this will be 0, this will be cancelled out, you will remain with 1. 0 factorial is equal to 1. 2c2 is equal to 1. So the answer for this term is 1. The answer for this term will be b power 0. B power 0 is equal to 1. So you will remain with a square. So a square is there plus a square. So I think now you have come to know that this is the formula. You can simply rearrange the terms. You may write it down as a square plus 2ab plus b square. So you may find these values using these from this binomial formula. Okay. Similarly, if you are interested in finding out this a cube, b cube, 3ab into a plus b, you can also use the binomial formula to find out this. Even if you are interested in finding out a plus b power 4, so you can use the formula. Okay, if you are interested in a plus b power 10, so you can do. So binomial formula will help you. Fine. Clear? Not clear? Not clear?
Clear, sir. Clear.
Clear, sir.
Okay, so for 3 you can solve it. Then one more thing, the average in this case is equal to NP, and the variance in this case is NPQ. So as previously we wrote the average for the discrete probability distribution as summation xpx, and the variance was summation x minus mu whole square px. So in this case, the average in case of binomial probability distribution, if you are interested in finding out average, this is the formula. If you are interested in finding out variance, this is the formula. Right? We can also prove these formulae, but that is not scope of a course. So if you are interested, we can solve it. Otherwise, we will leave it. No problem. Those are very easy. Are you interested? Should I solve? Should I prove these formulae? Should I prove these two formulae? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Yes. Okay. So I'm saying that mu is equal to NP. I'm going to derive it. Mu is equal to NP, okay, in case of binomial probability distribution. So now, basically, this term you will see in econometrics. Uh, Mu is equal to, I'm basically deriving mu is equal to NP. So I'm starting from this point. Mu is equal to expected value of x. Mu is equal to expected value of x. Basically, if you see what is the average value? Average value is the value that we may expect. Okay. So in econometrics, you will frequently see this EX. EX means average value, expected value, or average value, or mean value. So I'm going to write it down as mu is equal to EX. Okay. So now, what is EX? What is EX? Average. So if you recall your memory in discrete probability distribution, what was EX? What was the mean? What was the mean value? Mu was equal to summation xpx. xpx. If you recall your memory, we have just done. We have calculated the values for this term. Summation xpx. Fine. If you recall your memory.
Yes, sir.
Okay. So now, uh, E of x, it is equal to what? Summation x p x. Fine. Fine. So now x may take any value from 0 to 1. X may take any value from 0 to 1. This x, random variable. It may take any value, right? From 0 up to 1. So let's say I'm going to write it down as x is equal to from 0, 1 to up to n. This is the final term. Then how can I write down this if this is the situation? I may write down it as summation x is from 0 to n. X is from 0 to n. And if this is the situation, x will be there as first term, and for probability of x, basically it is probability of x is equal to x. X is equal to x. This is the situation because this is the number of successes in population, number of successes in sample. If capital X is equal to small x, then what this means? Here in this case, you can use binomial probability distribution formula. And we have already proved that what is the answer for this when x is equal to x. I have just written over here. See, is it there? Probability of x, we have proved it. We have proved that x is equal to x, then ncx p power x q power n minus x will be there. Is it or not?
Yes, sir.
So now write down this term over here. In next step, you may write down summation x is equal to 0 power n. This is that x, and here you may write down ncx p power x and q power n minus x. Fine. Now x is from 0 to n. X is from 0 to n. So now let us expand this, and we are using 0. We are writing down x is equal to 0 first. So the first term, now summation, this summation sign is not gonna be written over here. Simply write down 0 for x. So if it is 0, then the 0 will multiply with the remaining terms, and the answer will become equal to 0. Is it or not? Plus summation sign is there. So next term, you have to add the next term, and then you have to add the next term up to n terms. Up to n terms you have to add. So the next term, when you will substitute 1 over here, it will become 1. Now answer will not be 0, but here it will become nc1 p power 1 q power n minus 1. Is it or not? Yes, it is. So there is no need of writing 1 here, because x is equal to 1 and 1 will be multiplied with any term, that term will remain same. So you can write down over here nc1 p power 1 and q power n minus 1. This will be the second term. The third term will be when you will substitute x is equal to 2. So this will become 2. This will become 2. In fact, 1 is here multiplying, but I am not writing down 1 over here because this term will be multiplied by 1 and it will remain same. But when you will substitute over here 2, so now 2 should be written over here because now it will affect nc2 p power 2 q power n minus 2. Similarly, terms will be there up to n. N will be there, multiply by ncn p power n and q power n minus n. This will be the situation. Okay. So now ncn will equal 1. q power n minus n, this will become 0. So q power 0 is equal to 1. So what will be the answer? Npn will be the answer. Npn will be the last term. Okay, so now let us write down again. There is no need of writing 0 again in the next step. Simply start from this point, nc1, 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 p power 1 q power n minus 1 plus 2 c, sorry, nc2, sorry, nc2 p power 2 q power n minus 2 plus so on, and the final term will be n p power n. Fine. Now see, what is nc1?
And how about 2, sir?
nc1,
2 in front of NC2.
no, nc1 is equal to what?
1.
nc1.
Yes, sir. NC1 is equal to 1.
No, nc1 is equal to n. See, n, so let me write it down in red. So you can write down this at some side. Okay, this is not part of this. nc1, this will equal n factorial divided by 1 factorial into n minus 1 factorial. Fine. So this will equal, when you will open this n factorial means n will be there, multiply by n minus 1 will be there, then n minus 2, n minus 3 up to n minus n will be there. But you have to stop the series over here, n minus n, and then put factorial and divide it with 1 factorial. 1 factorial means 1. So there is no need of writing that. N minus 1 factorial will be the denominator, and you will cancel it out. Cancel it out with this term. So you will remain with n. So nc1 is equal to n. Clear?
Okay, sir.
So this n you will write down over here. N. This will be written over here. N p power 1. There is no need of writing p's power, because p power 1 is equal to p. Q power n minus 1. This will be written. Q power n minus 1. Now nc2. What is nc2? When you will open it, what will be the answer? nc2. nc2. So this will equal n factorial divided by 2 factorial into n minus 2 factorial. Right? And then you may open it and see another thing is there, but that will be seen later on. See, where was I? Where was I? Yes, this is 2. This 2 is there. So 2nc2. 2nc2 means if you multiply this with 2, so 2 will be here. Sorry, this was n1. nc1. nc2 is here. So 2 is here. This 2 is, I am writing down from here. This 2. This 2. If you are interested in cancelling out this 2, so you may write it down over here. Otherwise, if you are not going to write it down, no problem. Okay, what will be the answer for this? This will be, when you open it, this will be, 2c2 means 2 is again there. I think this 2 may confuse you. Should it be written, or should I remove it? I think it should be removed. It will confuse you. Okay, nc2 is equal to n factorial divided by 2 factorial. So n factorial, when you will open it, it will be n into n minus 1, and series continues n minus 2, and I am putting factorial sign over here because I want to stop the series over here. In fact, it will go up to n minus n. So I'm going to stop it over here, n minus 2. And then 2 factorial is there, that is equal to 2 and n minus 2 factorial, the denominator. So this will be cancelled out with this, and you will remain with n into n minus 1 divided by 2 factorial. See, is it or not? This term will be cancelled out. Only this will remain. So this 2 that is there in the denominator, it will be cancelled out when you will substitute NC2, the value for NC2 over here. The value for NC2 when you will put over here, NC2. So 2 is there in the denominator, that will be cancelled out with this 2. And you will remain with n into n minus 1 power n into n minus 1 into p. So this is the first term. The second term will be 2 will be cancelled out, n into n minus 1 power p power 2 and q power n minus 2. This will be there, n power 2, q power n minus 2. It is there. So this will remain same. And similarly, when you will solve for other terms will be there. And finally, when you will solve it for this, you will have this term. So we have already have this term, npn, npn. So npn is there as last term. So plus so on, plus n. This is the last term. Right? So now there is a trick. There is a trick. What you have to do? You can see NP is here, N and P is here in this term, N is P. So NP will be there in all terms. NP will be there in all terms. So what can you do? You can take NP common from all terms. So when you will take NP common, this will become mu or EX will equal NP. You are going to take this NP common. So what will be there? NP out, q n minus 1 will remain there in the braces. Q power n minus 1 plus next term. NP is out. NP out from here, and we will remain with n minus 1p. You will remain with NP is out, so you will remain with, see, remain with what? Here NP out, NP out. So P's 1 power will remain over there, and n minus 1 will be there. So n minus 1p, n minus 1p. Minus 1p. Why p? Because 1p is out, and q power n minus 2. Q power n minus 2. Fine. And finally, the final term is so on up to the final term will be npn. N is out, 1p is out, so you remain with p power n minus 1. P power n minus 1 will be there. Am I right? This will be there because 1 p is out and 1 n is out. Vasam?
Yes, sir. Yes, sir.
P power n minus 1 will be there because 1 power of p will be out and n will be out. So 1 power of p out means you have to subtract 1 from n.
Yes.
When you will
Okay,
add
sir.
1 p in this, it will become p power n. So 1 p is out, it means n minus 1 is there. Okay. So now when you will write this, you can see q power n minus 1 is the first term and the last term is p power n minus 1. As we wrote a square plus 2ab, fine, plus b square was there. So it looks like that. So q power this and finally p power this, as a square was there and finally b square was there, a cube was there, b cube was there. Similarly, q power this and p power this, and this was the central term. So there are so many terms in between these two. One term is this. So n minus 1 power. So if you write it down in compact form, you may write it down as np that you took common into q plus p power n minus 1, q plus p power n minus 1. Can you write it down as you wrote a plus b whole square, a plus b whole cube, a plus b whole power 4? Similarly, q plus b power n minus 1. When you will open it, you will have this. This is the compact form. This is the expanded form of the binomial. Fine. You can check it. When you will open it, so first term will be n minus 1 c1. Okay. And q power 1 p power n minus 1 minus 1. Like that. So this is the final term. And you know, the events are mutually exclusive, as we have already said in case of binomial probability distribution. They are independent. So therefore, and also they are exhaustive. So therefore, the sum of the probabilities will equal 1. So this is the probability of failure. This is the probability of success. So sum for the probabilities will equal 1. So it means that the power of 1 is n minus 1. So it doesn't matter what is the power of n. Whatever is the power of 1, the answer is 1. Fine. So this is basically np and 1 power n minus 1. So 1 power n minus 1 or 1 power n or 1 power, we don't know what is the value. Whatever is the value for that, the answer will be 1. So np multiplied by 1. This is the answer. And this is the proof of that this ex equal to mu. Understand?
Yes, sir.
Similarly, the proof for variance, we can also prove that, but that is slightly more complex. But we can do it. If you are interested, I can do. Otherwise, I will solve the question from this. But remember that in case of variance, we will have this term as our answer, npq. We can prove it also, no problem. Yes. Should I prove or fine? No problem. Yes. What is your opinion? Should I solve the question or should I solve it for variance? Hasnat Ali has left the meeting. I don't know what is the reason. So I don't want to put you in trouble. You can see the solution for variance also. I don't know whether your econometrics teacher will prove it or not, but it is very easy. I can simply write down 1 or 2 steps that you may further solve to find out that. So basically, in that case, sigma square is equal to, you have to consider this, expected value of what? Expected value of scared deviations from mean. Scared deviation from mean. So you have to write down this step as your first step, and then it will become easy for you to solve the question. So as E is there and this term is there, okay. So on opening this term, what will be the situation? Let's say E is equal to E into, this will be x, and we have said that mu is equal to ex. Mu is equal to ex. So takes care of this, right? And then open the square. So see what is the answer. E into x square will be there plus 2x ex, okay, plus ex whole square. Am I right? I have opened this. Sorry, this will be with negative sign. Here it will be negative sign because negative is here. So negative sign will be here. a minus b square, a minus b whole square, a square minus 2ab plus b square. This is the formula. So minus is here.
Yes, sir.
So from here onward, you can solve it. So there is some complexity in that how would we solve it, but you can solve it. If you are interested, you can solve it. Otherwise, you may ask me. I can solve it, no problem. So what is your opinion? Should I solve or not? Yes. Quick response is required. You are quite. Why? I don't know. Why are you silent?
I want to know another decision, sir. It's okay to solve problem right now because
Should I go for it?
it will be okay, sir, for time being.
So if you write it down, if you solve it for this ex square, I mean, if you write it down as ex square, ex square is equal to what? Can I write it as basically it is slightly complex. E into x minus 1 plus x. If you solve it for simply this ex square, because definitely when you will open it, e into x square will be there, and then 2 ex whole square, and then ex whole square. Okay, so when you will solve it, one term will be e of x square. So e of x square will equal like this. So if you open it, it will become x square minus x plus x. So minus x plus x will be cancelled out, and you will remain with ex square. So ex square is equal to this, no problem. But Sam, is it clear? If you open it, it will become x square, then minus x, and then this plus x. So you can write down x square as this. But this will help in solving the question.
Yes, sir.
So you may write it down as e of x into x minus 1 plus e of x. Fine. So on further solving, you may write it down as x into x minus 1. As you saw in case of ex, what we wrote np. For ex, it was np. For ex, it was np. And for ex minus 1, it will be n minus 1p. It will be n minus 1p. So therefore, we can write it down as n p for x, e of x, and e of x minus 1 will be n minus 1 p. Okay, plus np. So this will be n into n minus 1 and p square plus np. Right? So this is the result for this term, and for remaining terms, this term and this term. So let us see for this term ex square. Ex square will definitely will be will be n. Ex is equal to np. So np n square p square will be there, because ex is equal to np. So when you take square of those, it will become n square p square. And then there are the other terms that are involved in between. So this will be equal to minus n square p square, and several other terms are there in between. So When you will open it, it will become n square minus n square p square, n square p square minus np square plus np minus n square p square. And this term is there in between. This term minus 2x ex, minus 2x ex. So minus 2ex ex, this will be there. Because this x is equal to, when you will apply expectation, it will become ex and ex. So ex whole square will be there. So basically this term will become minus 2x. So this will become basically like this. Let me solve it. It will be 2e. Let me see again. 2. Where is this? Yes, 2x ex. 2x ex. Okay, when you will apply expectation on this, this will become 2 out. So basically there are two operators. One is called the expectation operator, the other is called the variance operator. So I am now taking help of expectation operator, and there are certain rules for these two. Okay, so you can apply expectation operator over here. It will become 2ex into ex. This is the result for this, and here you will write down 2ex whole square. So now you can see this is with negative sign over here. There is negative sign over here. This is negative sign. So this is equal to 2ex whole square, and this is one part. This is this is one time with positive, and the same is there with 2 times with negative sign. So the result will be with negative sign. Okay. So this is what you have to write down over here. This will be positive. This will be positive. And for this, I have already found the result will be np square. So basically, this will become minus 2 np square. What is this? This is 2 np square, n square p square. This is equal to 2 into n square p square. So n square p square minus np square plus np plus n square p square minus 2n square p square. Fine. So now you can see this term, this term, this term gone. Okay, and from the remaining terms, you can take np as common. Np as common. So you will remain with what? Np into, here it will be np1. So this will be 1, and here you will remain with p. 1 minus p. 1 minus p. 1 minus p is equal to q. So the result is npq. This is the result. Clear? So Sam, I have done it for you because
Okay.
only you said that, sir, please solve it. Otherwise,
Okay.
so now as I have solved it. So now I think it is easy for me to prove. No problem.
Okay.
Okay.
Thank you, sir.
So now I'm going to solve only 1 or 2 questions quickly uh, to see that how you will use the binomial formula. Let's say the question is, a fair coin, a fair coin is tossed 5 times. A fair coin is tossed 5 times find probability of occurrence of various number of heads, coin tossed 5 times. So now you may write down the probability distribution. How? See, first is that no head has occurred. No head has occurred. So x will equal 0. Small x is equal to 0 in this case. No head occurred. Okay. And total trials are 5. Coins were tossed 5 times. So 5 is equal to n is equal to 5. C, 0 head has occurred. What is the probability of success? 0.5 is basically, if you see, 50% are the chances that head will be there. 50% are the chances that tail is there. So this is P, this is P, this is Q. Okay. And you are saying that no head has occurred, so probability for head was 0.5, so its power will be 0. And 5 minus 0 will be there. 5 minus 0 is equal to 5. It means that 5 times tail has occurred, and not for a single time head was there. Fine. 5c0 is equal to 1. 0.5 power 0 is equal to 1. 0.5 power 5, what is this? Point 0.5 power 5. Yes, what is the answer? I don't have its answer because my calculator is so old. Okay, I purchased it in 1993, and it sometimes works, and sometimes I think because of perhaps its cell, battery cell is its battery is out of order now. It's so weak, therefore it's not working. So yes, Basam, 0.5 power 5. The answer is
1, sir.
1.
No, all is 1.
So definitely the sum for the x0, x1, x2, x4, 3, 4, 5. So definitely the sum will be 1. But what is the probability in this case when no head is there? I think I should use my mobile for this. 0.5 power 5. The answer is 0.87. 0.55, so 0.87. Similarly, you have to check it for x is equal to 1, then x is equal to 2, then x is equal to 3. So for all you have to check. So in this way you will distribute the probabilities. X is equal to 5, sorry 4, and finally p x is equal to 5. So one by one you will write down, and finally you will add the probabilities. The answer will become equal to 1. This is what you are saying, the sum. Is it? So let's say for 3 it will be 5c3, 0.5 power 3, and 0.5 power 5 minus 3, 2. So p power 3, q power 2. So you can solve it and you will have the answer. Can you solve it quickly if you are interested?
Yes, sir.
Please, if you will help me, I will be, I will feel easy to, because there is one other table after this, and we will conclude then after making that table. But for that, you have to write down this. So the next will be 5C1. So instead of writing 0.5, I may write it down as 1 over 2. 1 over 2 power 1 and 1 over 2 power 4. So I think it is further easy. 5C1 is 5 and 1 power 2 power 1. This is 1 by 2 and 1 by 2 power 4. So 11632. So it will be 5 divided by 2 power 2 4 power 3 8 power 4 16 is 32. So this is 16 basically, power 4 16. So 16 multiplied by 2 32, 5 by 32. Similarly 5C2 into 1 by 2 whole square into 1 by 2 whole cube. So 5C2 is equal to what? So there will be 32 in all cases in denominator. Only you have to find out 5C2. 5C2. Let 10. So the answer for this will be 10 by 32. Okay, so you can see this 0.87. Basically, if you see this, 1 over 2 power 5. 1 over 2 power 5 is equal to 1 over 32. 1 over 32, you can find it out. Sorry, yes, 1 divided by 32. What is this? 0.5 power. This is 0.03, not 0.87. This is 0.3. 0.03. So you can check it. 1 over 32, then 5 by 32, 10 by 32. In this case, again, 5C3. 5C3, the answer is 10. So 10 by 32. In this case, it will be 5C4. That will become 5. So 5 by 32. It is verbal. No problem. Basam, understand? I don't know why others are not participating in this, but at least you are participating. So 5C5 will become 1. So this will become 1 by 32. So when you will add this, 1 plus 5, 6, 16, 26, 26 plus 5, 31, 32. So 32 by 32 is equal to 1. 1 is the answer. So now here you will write down the probability distribution. How will you write down? You write down X, and here you write down probability of X. So what is X? Number of heads in 5 trials. So no head, 1 head, 2 head, 2 heads, 3 heads, 4 heads, or
सर आज के लिए इतना
5 heads.
काफी है.
Yes, it is the last table that I am going to make. Probability of X 0 or 0. When it was 0, the probability was this. So now this is the probability distribution table. So 1 by 32 you will write down over here in the table. 1 by 32. Next, for 1 it was 5 by 32. 5 by 32. You will write down over here 5 by 32. For 2, you have to see, for 2 it is 10 by 32. For 3, 10 by 32. 10 by... So Basam, help me.
Yes, sir.
Writing down the probabilities in this
by
table.
32.
Because I can't scroll again and again. So therefore, please help if you have
Okay.
written it with your pen.
Okay, sir.
Yes, this is the table.
Yes.
5 by 32. For 2 it was 10 by 32.
10 by 32.
For 3 it was 10 by 32.
Yes, sir.
And
Fi-
for 4
5
it
by
was
32. 5
5
by
by
32.
32. Thank you. And 1 by 32.
1 by 32, yes, sir.
So the answer was 1. So this is the probability distribution table basically in this format, x and px, x and px. So we have basically distributed the probabilities in this case. So this is all for today, and we shall try to solve few more questions in the next class, and hopefully next class will be there in the next week, upcoming week. So definitely in next class we shall try our best to complete few more things. Inshallah.
Okay, sir. Thank you.
Thank you very much for your patience, and let me, if you have any question, you may ask right now.
Inshallah, sir.
So I'm going to stop the recording. If you wanna have, if you wanna ask any question, you may ask. Everything is clear. Whatever we have studied today, I think everything is clear.
Yes, sir. Clear, sir.
Okay. Thank you very much.